Alright, now we look to examples of applications that require a quadratic equation. Not that you might not encounter those on the other types, but they weren't in the examples that I've already shown. The first type I'm going to look at has to do with the Pythagorean Theorem. And there's my not so good drawing of a right triangle with the legs measures of A and B and the hypotenuse measure of C, and a reminder that A squared plus B squared equals C squared. It says a sail on a sailboat is in the shape of two adjacent right triangles. The hypotenuse of the lower triangle is 10 feet and one leg is 2 feet shorter than the other. Find the lengths of the legs of the lower triangle. So even though there's two right triangles, we only need the lower right triangle. So I'm going to draw a picture here and I'm going to do some labeling. Not a very good right triangle, sorry about that. And we know that the hypotenuse is 10 feet. But we do not know the lengths of the legs. It just says one leg is 2 feet shorter than the other leg. So I'm going to let x be the length of the longer leg. So that means that x minus 2 would be the length of the shorter leg. And I'm going to go ahead and denote that. We'll call this one here x, and this one is x minus 2 to try to make it look relative to the size of the triangle I've drawn. Alright, well, the Pythagorean Theorem is going to carry us through here. We know that one leg squared plus the other leg squared, the lengths, is equal to the length of the hypotenuse squared. So that was a little bit easier equation to come up with than maybe the last example, or the one before that. We're going to go ahead and solve this equation. I have to expand that. I have x squared plus using FOIL or squaring a binomial minus 4x plus 4 equals 100. Combine like terms, and I'm going to subtract 100 from both sides. 2x squared minus 4x plus 4 minus 100 equals 100 minus 100. So I have 2x squared minus 4x minus 96 is equal to 0. And if I divide through by 2, I have x squared minus 2x minus 48 is equal to 0. I have to divide every term, both sides, by 2 to simplify it down here. This one factors, which is really nice. And I have x minus 8 times the quantity x plus 6. So using the zero product property, I set this equal to 0. I set x plus 6 equal to 0. I'm running out of space here, but I'll have to put the answer over there. I have to add 8 to both sides. Oops. 0 plus 8, I have x equals 8. Over here I'll subtract 6. You can see this one probably coming, that I get a value that's not going to be of any help because x is the length of a side. It can't be negative. So there's only one logical answer, and that answer is x is equal to 8. So let's see what we have here. If x is equal to 8, and this is in feet, then x minus 2, this would be 6 feet. So now it says find the lengths of the legs of the lower triangle. Last step, the lengths of the legs of the lower right triangle are 6 feet and 8 feet. And there's my answer. And if you remember your Pythagorean triples, you remember the 3, 4, 5. Well, this is a multiple of that, the 6, 8, 10. Well, my computer's happy anyway. All right, let's look at the next example. I did not probably give myself enough space, so I'm going to probably have to erase this, or at least part of this, to finish this problem off. This has to do with a problem that you'll see in calculus involving vertical motion. I varied it just a little bit from the textbook. In the textbook, the formula that they give you is slightly different because they list gravity as a positive number rather than a negative number. They'll put a negative in front of the 1/2 here, but gravity is pulling the force down, so we write gravity as a negative amount, a negative acceleration. It says vertical position of an object moving vertically under the influence of gravity. So if I take my pen and I throw my pen up, I have an initial height, I have an initial velocity. That's what these are. This is representing the initial height from which the object is leaving. This is the initial velocity from which the object is traveling at. G is gravity and T is time. They use s a lot of times instead of h for the height of the object, the position of the object. It's a vertically moving position, and we neglect air resistance. So if our measures are given in feet, then we use gravity to be negative 32, so we'll put a negative 32 in here. 1/2 times negative 32 is going to be negative 16. If we use meters, then we'll put negative 9.8 in here for gravity. 1/2 times negative 9.8 will give us negative 4.9. But again, this is the initial velocity, this is the initial height, and t is our time. It says here in this example, a fireworks mortar is launched straight upward from a pool deck 2 meters off the ground. Well, if it's launched from a pool deck 2 meters off the ground, right there, this is your initial height. This is s sub 0. And with an initial velocity of 40 meters per second, so this is v sub 0. So I already have a couple of the themes that I'm doing here, and this is in meters per second, so I'm going to be using gravity at negative 9.8 meters per second. Write a model, and that's going to be based on this formula up here. Write a model to express the height of the mortar x, okay, so they're changing the s to an x, in meters above ground level. So x equals 1/2 times negative 9.8 t squared plus, going upward, 40 positive t from an initial height of 2 meters, plus 2. Or better yet, x is equal to negative 4.9 t squared plus 40t plus 2. Now that we have that, we're going to use that to solve part B. Find the time or times at which the mortar is at a height of 60 meters, and then we'll also do 100 meters if we have the space there. And we're going to round it to the nearest tenth of a second. So we're going to plug 60 in here for the height of the object. 60 equals negative 4.9 t squared plus 40t plus 2. And we're going to solve this equation, and it is a quadratic, as you can see. We're going to solve for t. I'm going to go ahead and subtract 60 from both sides. And I'm kind of lazy because I know I'm hurting for space, so I'm just going to write minus 58. And I'll forgot a variable. Let's not forget the t. And then I'll probably go ahead and do myself disservice if I leave it with a negative there. So I'll multiply through by negative 1 as well. And I'm going to write 4.9 t squared minus 40t plus 58 is equal to 0. Well, good news and bad news. I've got a nice quadratic, but it's not going to factor conveniently, so I have to use the quadratic formula. Not that that's the world's worst news, but a is 4.9, b is negative 40, c is 58. So I'm going to take the opposite of b, plus or minus the square root of b squared minus 4 times 4.9 times 58. All over 2 times 4.9. Well, this starts to get real messy, and avoid problems with this, I went ahead and I did this on a piece of scratch paper so that I could speed this process up a little bit. And what I ended up with was 40 plus or minus the square root of, and it's a pretty good size number here, 1368.32, and that's all going to be over 9.8 when I multiply here. So I'm going to get my calculator out, and I'm going to find both values, when it's plus and when it's minus. And when I do this and round to the nearest tenth, I get this to be 1.9 and 6.8 if I'm not mistaken. I better check my arithmetic here. Good thing I checked it, 6.3. Now you're wondering, well, how does it have 2 times? Well, it starts out here 2 meters off the ground. It goes up, passes the 60 meter mark on the way up, passes the 60 meter mark on the way down. And so it's going to do this, find the times. The object is 60 meters above the ground at 1.9 seconds and at 6.3 seconds. All right, there's the answer to the 60 meters. Now, the 100 meters, I went ahead and did that example, and this is where I'm going to probably have to erase a little bit over here. It's because I wanted to show you something where it maybe looks like the problem is wrong, but if I put 100 here, and I solve for t, I subtract 100, I multiply through by a negative 1, I'll get 4.9 t squared minus 40t plus 98 is equal to 0. And I use the quadratic formula and I get t is equal to 40 plus or minus the square root of negative 40 squared minus 4 times 4.9 times 98 all over 2 times 4.9. What happens is this turns out to be a negative amount. So that means you have an imaginary number. Well, this is a real application. You're not going to have an imaginary time. All right, so what happens here is this indicates that the object never reaches 100 meters. It doesn't go up that high. In fact, since we will study the ideas of parabolas a little bit later, I know we've talked about them just briefly, but if you were to find the vertex of this parabola that opened downward, setting up in terms of two variables, you would see that the vertex would not have a y value greater than or equal to 100 meters. So in this case, it's not going to reach 100 meters. So the object does not reach a height of 100 meters. So you should write out your answers, kind of nice and neat, and that hopefully will give you a good idea of what you'll need to do with some of these quadratics. Now, there are many kinds of story problems in this particular section of the book. This is excellent review, but it is going to take a great deal of practice, practice, practice.